Earth's orbit is a high-speed battleground you might not think about, yet it's one that grows more chaotic every single day. Right now, millions of fragments of old satellites, rocket parts, and other debris are hurtling through space at speeds fast enough to shatter anything in their path. These fragments may be out of sight, but their impact is anything but threatening the satellites we rely on for everything from weather forecasts to global communications. But here's where it gets fascinating. Out of this chaos, an incredible solution is emerging. Imagine futuristic drones engineered with precision, taking on the challenge of cleaning up our orbital junkyard. These high-tech cleanup crews might just hold the key to safeguarding our digital future and preventing catastrophic collisions in space. So, how exactly would this work? Let's dive into the details of this groundbreaking mission to reclaim our skies. Every day above our heads, over 100 million pieces of space debris zip around Earth at staggering speeds of up to 17,000 miles per hour. That's faster than a speeding bullet by about 10 times. These fragments, often no larger than a marble, might seem insignificant, but their potential for destruction is anything but small. Collectively, they form what scientists call space junk or orbital debris, a problem growing so severe it's been compared to a cosmic minefield. But what exactly is this space junk and why should we care? Space junk is the detritus of decades of space exploration. It includes decommissioned satellites that no longer serve any purpose, scraps of metal from rocket launches, and even tools or paint chips that have floated loose during space missions. Some of it comes from explosive collisions between objects in orbit, which break apart into countless smaller fragments. Many of these pieces are tiny, but even a piece the size of a screw can puncture spacecraft walls or disable vital satellites thanks to its incredible velocity. And the larger objects, well, they're like ticking time bombs. A single collision could create thousands of new fragments, multiplying the problem exponentially in what experts call the Kessler Syndrome, where debris collisions trigger a chain reaction, making certain orbits unusable for decades. This growing cloud of debris poses a significant threat in ways that ripple back down to Earth. Think about it. Our daily lives depend on satellites more than we often realize. They power GPS for navigation, provide telecommunication networks, help track weather patterns, and even facilitate international banking transactions. A single piece of debris striking a key satellite could knock out internet access, disrupt television broadcasts, or degrade global positioning systems. Beyond that, the International Space Station has to regularly adjust its orbit to dodge potential collisions, a costly and risky maneuver. And as space exploration ramps up, with new missions to the Moon and Mars and the rise of commercial space ventures, the crowded orbit becomes not just an inconvenience but a genuine danger. This isn't just about losing services or impeding exploration. There's also an international security element. Satellites play critical roles in defense systems, enabling communication during crises, monitoring military activities, and even detecting missile launches. A collision that takes out a defense satellite, whether accidental or deliberate, could escalate geopolitical tensions or leave nations vulnerable. And as more countries and private companies launch satellites, the competition for safe orbital real estate grows fiercer, increasing the chances of accidents. The urgency of solving this crisis cannot be overstated. With every new launch, we add to the problem, and the longer we wait to act, the more difficult cleanup becomes. Earth's orbit is a finite resource, and if we don't address this growing menace soon, we risk locking ourselves into a future where space is too dangerous to use. So the question is, what can we do to reverse this trend? To understand how we got to this point, where Earth's orbit is filled with millions of pieces of space debris, we need to take a step back in time to the dawn of space exploration. It all started in 1957 with the launch of Sputnik 1, the world's first artificial satellite. Weighing just over 180 pounds, Sputnik ushered in a new era of human achievement. But what many don't realize is that it also marked the beginning of what would become a growing problem: space junk. In the early days, space launches were few and far between. The concept of orbital debris wasn't even on the radar. Every mission was focused on pushing boundaries and making history. However, as the number of satellites and rocket launches increased, so too did the amount of debris left behind. Old rocket stages, defunct satellites, and even tools dropped by astronauts began to accumulate in Earth's orbit. Unlike objects left on Earth's surface, this debris didn't simply disappear. With no atmosphere to slow them down, these fragments could remain in orbit for years, even centuries. But natural accumulation wasn't the only factor at play. Collisions between satellites and other objects in space have created cascading clouds of debris. Imagine two satellites accidentally smashing into one another at speeds of tens of thousands of miles per hour. The result is an explosion of fragments, each piece becoming a new hazard to other satellites. In 2009, for example, an active communications satellite collided with a defunct Russian satellite, creating thousands of new pieces of debris in an instant. Each of those fragments then became a potential trigger for future collisions, leading to a dangerous chain reaction. And then there's the role of human activity, like anti-satellite missile tests. These tests, conducted by several nations over the years, intentionally destroy satellites to demonstrate military capabilities. While dramatic, the aftermath of these tests is catastrophic for Earth's orbit. Take the 2007 test by China, where an anti-satellite missile destroyed one of its own weather satellites. This single act created over 3,000 trackable pieces of debris, pieces large enough to pose a major risk to other satellites and the International Space Station, with even smaller fragments adding to the chaos. All of this brings us to the concept of the Kessler Syndrome, a scenario first proposed by NASA scientist Donald Kessler in 1978. He warned that as the density of objects in orbit increases, the likelihood of collisions grows exponentially. Eventually, these collisions could trigger a runaway effect where debris generates more debris, making certain orbits completely unusable. In the worst-case scenario, this chain reaction could create a belt of debris so dense that launching anything into space or even venturing beyond Earth would become nearly impossible. Imagine a future where the very tool we rely on for exploration, communication, and global progress is rendered useless, trapping humanity on Earth. This isn't just a theoretical idea, we're already seeing the warning signs. Today, every satellite launch must factor in orbital space debris, plotting courses to avoid collisions, and space agencies routinely track tens of thousands of objects in orbit, issuing alerts when debris comes too close to spacecraft. These precautions help for now, but as the orbital environment becomes more crowded, the risk of a catastrophic event grows. The buildup of space junk is a problem decades in the making, fueled by a mix of innovation, oversight, and the unintentional consequences of human ambition. But now that we understand the scale of the problem and how we got here, the question becomes, what can we do about it? How do we mitigate the damage already done and prevent the Kessler Syndrome from becoming an inescapable reality? Let's explore the groundbreaking solutions that could change the course of our orbital future. Picture this: in 2021, a piece of space debris came perilously close to a functional satellite belonging to OneWeb, a company providing global internet coverage. The debris was traveling at nearly 17,000 miles per hour, and a collision seemed imminent. Thanks to last-minute tracking and maneuvering, the satellite managed to dodge the fragment by just a few hundred meters, a terrifyingly close call when you consider the speeds and stakes involved. Satellite operators face scenarios like this regularly, constantly monitoring for potential impacts and scrambling to adjust orbits at the faintest sign of danger. It's a high-stakes game of cosmic dodgeball, and it's becoming harder to play as the number of objects in orbit skyrockets. These near misses are not isolated incidents. In fact, there are over 2,500 active satellites in orbit today, surrounded by a swarm of over 36,000 trackable pieces of debris. Beyond that, there are millions of smaller, untraceable fragments still large enough to cause damage. Every single one of these objects poses a potential threat, and the situation is only getting worse. Each new collision or breakup event adds more debris to this already chaotic environment, increasing the odds of chain reactions. This brings us back to the looming specter of the Kessler Syndrome, a cascade of collisions so severe that it could render certain orbital altitudes unusable, effectively trapping satellites and new missions on the ground. Imagine this scenario. A crucial altitude used for GPS satellites becomes so crowded with debris that it can no longer be used safely. GPS, which we rely on for everything from navigating in our cars to coordinating emergency services, would be severely disrupted. But the ripple effects wouldn't stop there. Air travel, shipping routes, and even precision agriculture, which uses GPS for planting and harvesting efficiency, would face chaos. Without satellites, global communication networks would falter, disrupting internet access, mobile networks, and even financial systems that depend on time-stamped satellite signals for transactions. Weather forecasting, too, would suffer, leaving us vulnerable to hurricanes, droughts, and other natural disasters that we currently monitor from space. The economic cost would be staggering, potentially reaching hundreds of billions of dollars as industries scramble to adapt to the loss of these critical services. Even more alarming is the potential impact on space exploration itself. If low Earth orbit becomes too hazardous, it could block humanity's path to the stars. Future missions to the Moon, Mars, and beyond could be delayed indefinitely or become prohibitively risky. The International Space Station, which provides vital research opportunities, would face heightened threats from collisions, potentially forcing an early end to its operations. Essentially, our ability to explore and utilize space, a cornerstone of technological and scientific progress, would grind to a halt. This isn't just a distant possibility, it's a pressing issue that demands immediate action. The longer we wait, the more difficult and expensive it will be to clean up Earth's orbit. Every new satellite launch, every rocket stage left behind, and every fragment created from a collision adds to an already overwhelming problem. The stakes are high not just for those in the space industry, but for all of us here on Earth who rely on space-based technologies every single day. That's why proactive solutions are no longer optional, they're essential. We need innovative strategies to address this crisis before it spirals out of control. From designing satellites to deorbit themselves at the end of their lifespan to deploying advanced technologies for debris capture and removal, the race is on to preserve Earth's orbital environment. Let's explore how brilliant minds and cutting-edge technologies are coming together to tackle this urgent challenge head-on. But what if the solution to the growing chaos in Earth's orbit isn't grounded in traditional methods, but instead comes from the skies themselves? Enter the futuristic drones, cutting-edge machines designed to take on the monumental task of cleaning up space debris. Think of them as the unsung heroes in the battle against the space junk crisis, quietly but efficiently restoring order to the orbital highways we depend on. These aren't your average drones, far from it. They're equipped with some of the most advanced technologies humanity has ever developed. Artificial intelligence sits at the heart of their design, enabling them to make split-second decisions in a constantly changing environment. Space is unpredictable and debris isn't stationary. Often, these fragments are tumbling, spinning, or moving erratically. That's where AI, paired with robotic precision and autonomous navigation systems, becomes indispensable. These drones are capable of tracking, identifying, and locking onto a piece of debris with pinpoint accuracy, even if it's moving at thousands of miles per hour. So, how does a futuristic debris cleaning mission actually unfold? Picture this. A drone is launched into orbit, programmed to target a specific area cluttered with debris. Using advanced sensors and imaging technologies, it scans its surroundings, identifying pieces of junk and prioritizing them based on a variety of factors like size, speed, and collision risk. Once the drone locks onto a target, the real work begins. Equipped with robotic arms, nets, or even harpoons, it carefully captures the object, taking into account its speed and rotation. For smaller objects, some designs even incorporate adhesive or magnetic surfaces to gather debris more efficiently, but capturing the junk is only half the battle. The next step is disposal, and this is where things get truly innovative. For larger debris, the drone might deorbit it, essentially steering it into Earth's atmosphere, where it burns up upon re-entry. This approach is particularly effective for defunct satellites or larger fragments that pose a high collision risk. For smaller debris, recycling is becoming an increasingly popular option. Some drone designs aim to process and repurpose the materials on site, converting, say, aluminum or titanium fragments into raw materials for future use. Imagine a future where the trash orbiting Earth is transformed into building blocks for new satellites or even spacecraft. These drones are also designed to work autonomously for extended periods, a critical feature given the vastness of space and the sheer amount of debris that needs to be tackled. Autonomous navigation allows them to move seamlessly between targets without constant input from ground control, reducing costs and maximizing efficiency. Some prototypes are even designed to work in swarms, multiple drones coordinating with one another to clean up massive debris fields, much like bees working together to pollinate a field of flowers. This swarm approach not only accelerates the cleanup process but also allows drones to cover larger areas of orbit in less time. The development of these futuristic debris removal systems is already underway. Companies like Clear Space, Astroscale, and government agencies such as NASA and the European Space Agency are investing heavily in these technologies. For example, Clear Space is working on a mission called Clear Space 1, which will use a robotic arm to capture a defunct satellite and deorbit it. Astroscale, on the other hand, is testing magnetic capture technology to dock with and safely dispose of debris. These missions are laying the groundwork for a new era where cleaning up space becomes as routine as launching satellites. But perhaps the most exciting aspect of these drones is how they represent a shift in how we approach space exploration. No longer is it just about getting to space, it's about sustaining it. These drones are more than just tools. They're symbols of innovation, responsibility, and the incredible potential of human ingenuity. They promise a future where Earth's orbit is no longer a minefield of junk but a well-managed, safe environment that supports the technologies and discoveries we rely on. And as these drones take to the skies, one piece of debris at a time, they're proving that even the most complex problems can have high-tech, elegant solutions. When it comes to battling the relentless swarm of space debris, the design and tools of futuristic space cleaning drones are nothing short of ingenious. These drones are built to operate in one of the harshest environments imaginable, zero gravity, where every action has an equal and opposite reaction, and even the tiniest miscalculation can send objects careening off course. To tackle these challenges, engineers and scientists have developed a wide variety of innovative designs, each tailored to capture and remove debris with precision and efficiency. One of the most straightforward yet effective solutions involves net catching systems. Imagine a drone deploying a large, flexible net to ensnare pieces of debris, much like a fisherman casting a net into the water. This approach is particularly suited for capturing tumbling fragments or clusters of smaller objects. Once trapped, the net can be reeled in, securing the debris safely for transport or disposal. What makes this method so appealing is its simplicity. No need for complex mechanical arms or precise docking maneuvers. However, it still requires incredibly accurate targeting systems to ensure the net reaches its fast-moving target in the vastness of space. For larger or more irregularly shaped debris, robotic arms offer a more versatile solution. These mechanical limbs are equipped with gripping mechanisms that can latch onto objects regardless of their size or orientation. The arms are controlled with remarkable precision, often guided by artificial intelligence. Robotic arms are ideal for tasks that require careful handling, like retrieving defunct satellites or rocket stages. Once secured, the debris can either be safely deorbited or stored for recycling. The European Space Agency's Clear Space 1 mission is a prime example of this technology in action. Its drone, equipped with robotic arms, is set to target and capture a defunct rocket component, marking a significant milestone in orbital cleanup efforts. Then there's the concept of harpoons. Yes, space harpoons. This might sound like something out of science fiction, but it's a highly practical solution. Harpoon-based systems involve launching a tethered spike into larger pieces of debris, allowing the drone to reel them in like a catch. The advantage of this method is that it can engage targets at a distance, minimizing the risk of a collision between the drone and the debris. The European Space Agency has tested such systems with promising results, showcasing how a well-aimed harpoon can securely latch onto objects traveling at extremely high speeds. But the innovation doesn't stop there. Some designs look to lasers to aid in the cleanup. No, these aren't the destructive lasers you see in movies. Instead, these lasers use short, focused bursts of energy to nudge debris onto a new trajectory, one that leads it into Earth's atmosphere where it burns up harmlessly. This method is particularly effective for smaller fragments that are difficult to capture physically. Ground-based laser systems are also being explored, which would allow debris to be handled without additional equipment in orbit. While still in development, laser systems hold incredible potential for non-invasive, remote debris management. Of course, operating in zero gravity presents its own set of challenges. Every action performed by a drone, whether it's deploying a net, extending a robotic arm, or firing a harpoon, creates a reactive force that could destabilize the drone itself. This means the onboard systems need to be finely calibrated to maintain balance and stability after every move. Thrusters and gyroscopes are used to counteract these forces, ensuring the drone stays on course and can continue its mission without interruption. This level of precision requires cutting-edge engineering and advanced AI to continuously adjust for the unpredictable dynamics of space. Companies like Astroscale are already making strides in this field. Their End-of-Life Services by Astroscale program involves drones equipped with magnetic docking systems designed to attach to defunct satellites. Once attached, the drone guides the satellite to a lower orbit for re-entry and disposal. This approach not only removes existing debris, but also encourages satellite operators to adopt designs compatible with magnetic docking, fostering better long-term sustainability in orbit. Together, these designs represent a remarkable fusion of engineering creativity and technological breakthroughs. Whether it's the simplicity of a net, the precision of a robotic arm, the reach of a harpoon, or the futuristic promise of lasers, these tools are transforming the way we approach space cleanup. With ongoing projects like Clear Space 1 and Astroscale's efforts leading the charge, it's clear that humanity is stepping up to the challenge of safeguarding Earth's orbit. As these technologies continue to evolve, we move closer to a future where space becomes not just a frontier of innovation, but also a model of sustainability. While the idea of futuristic drones cleaning up space debris sounds like the perfect solution, the reality of implementing these cleanup missions is far more complicated. The challenges involved are staggering, from enormous costs to legal entanglements and the very real risk of making the problem worse. The road to a cleaner orbit is paved with obstacles that demand careful consideration and global cooperation. Let's start with the financial burden. Developing, launching, and operating space-cleaning drones doesn't come cheap. Each mission requires cutting-edge technology, extensive testing, and the deployment of highly specialized equipment. Just launching a single kilogram of payload into orbit can cost tens of thousands of dollars, and cleanup missions often require multiple launches to tackle even a fraction of the debris. On top of that, there's the cost of research and development. Designing drones that can navigate and perform complex maneuvers in zero gravity is no small feat. For private companies, these costs are a major deterrent, especially since there's little immediate financial return. After all, space debris doesn't come with a price tag. Unlike telecommunications, satellites, or commercial space ventures, cleaning up orbit lacks a direct revenue stream, making it a tough sell for investors. Then there's the legal minefield. Space debris isn't just trash floating in orbit, it's property. Under international law, any object launched into space remains the responsibility and ownership of the country or entity that put it there, even if it's been abandoned for decades. This creates a massive legal gray area when it comes to cleanup efforts. For example, if a drone captures a defunct satellite, who has the right to authorize the removal? And what happens if the cleanup process inadvertently damages another country's functional satellite or infrastructure? These questions aren't just theoretical. They need clear legal frameworks to avoid escalating tensions in an already competitive and crowded orbital environment. So far, no comprehensive international agreement exists to address these ownership issues, leaving cleanup missions in a precarious legal position. But perhaps the most daunting challenge lies in the risk of further collisions during cleanup. Space debris isn't stationary. It's hurtling through orbit at mind-boggling speeds, often in unpredictable patterns. Capturing these fragments requires incredible precision, and even the slightest misstep can lead to catastrophic consequences. Imagine a drone misjudging a piece of tumbling debris and accidentally striking it instead of securing it. The impact could create hundreds or even thousands of new fragments, exacerbating the very problem the mission set out to solve. This risk, known as the creation of secondary debris, is one of the biggest deterrents to large-scale cleanup operations. It's a constant reminder that any solution must be executed with the utmost care to avoid making the situation worse. These challenges highlight the need for something space exploration has always struggled with: international collaboration. Cleaning up space debris isn't a task that any one country or organization can tackle alone. For one, the problem is global. Debris doesn't respect borders. It orbits Earth, creating risks for every nation and every satellite operator. Addressing it requires coordinated efforts, shared resources, and unified guidelines. This means coming to agreements on liability, ownership, and best practices for debris removal. It also means establishing new regulations to ensure that satellite operators and launch providers take responsibility for the objects they put into orbit. Some progress has been made in this area, with initiatives like the United Nations guidelines on the long-term sustainability of outer space activities, but there's still a long way to go. So, how does the futuristic drone concept address these challenges? For starters, these drones are designed to operate autonomously, reducing costs by minimizing the need for constant human intervention. Their modular designs also allow for multi-purpose missions, combining debris capture with satellite servicing or recycling operations to create additional value. Moreover, new technologies like artificial intelligence for precision targeting and advanced robotics for safe handling are specifically aimed at minimizing the risk of secondary collisions. On the legal front, many companies are working closely with governments to test these systems in controlled conditions, paving the way for clearer international policies on ownership and liability. While the hurdles are significant, they're not insurmountable. These challenges have forced the industry to innovate, collaborate, and rethink how we approach the problem. And as we'll see next, the same technologies designed to clean up space debris could also be laying the groundwork for a more sustainable and cooperative era in space exploration. The battle against space junk isn't one that any single nation, company, or agency can fight alone. This is a global problem that demands a global solution, and fortunately, international efforts to tackle it are beginning to gain momentum. Space agencies, private companies, and even multinational organizations are coming together to address the ever-growing threat of space debris. At the heart of these initiatives is not just the shared urgency of protecting Earth's orbit, but also the potential for futuristic drones to become the primary tools in this collaborative effort. Take NASA, for example. The agency has been at the forefront of research and development on orbital debris for decades. NASA Orbital Debris Program Office actively tracks tens of thousands of objects in orbit, creates models to predict future debris scenarios, and researches technologies to limit debris creation in the first place. They've also partnered with other agencies and institutions around the world, sharing data and best practices to help mitigate the risk of collisions. Projects like NASA's Remove Debris Experiment have tested methods such as net capture and harpoon technologies, paving the way for more ambitious missions in the future. Meanwhile, the European Space Agency ESA is fully committed to making space sustainability a top priority. The ESA is spearheading Clear Space One, the first mission of its kind, which will deploy a robotic drone to capture a piece of space debris and deorbit it safely. What's remarkable about this mission isn't just its technical sophistication, but also the broader message it sends about Europe's leadership in space cleanup. The ESA has also worked closely with international partners, calling for guidelines that require satellite operators to deorbit their spacecraft at the end of their operational lives, reducing the amount of future debris. Private companies have also entered the fray, bringing innovation and speed to an issue that needs urgent attention. Astroscale, a Japan-based company, is developing technologies to service satellites and remove orbital debris using magnetic docking. Their approach combines business with sustainability, offering operators a way to extend the lifespan of their satellites while also addressing the debris problem. Another notable player, Northrop Grumman, has developed the Mission Extension Vehicle, which focuses on servicing aging satellites instead of abandoning them to become future debris. These companies are introducing new frameworks for how businesses can profit from actively participating in space cleanup, showing that sustainability and profitability can go hand in hand. But the real key to progress lies in international collaboration. Space debris is everyone's problem and affects every nation that relies on satellite technology, and that's virtually every nation on Earth. Treaties and agreements will play a critical role in formalizing global efforts to clean up orbit. For example, the United Nations has already established guidelines for the long-term sustainability of space activities, encouraging responsible practices for satellite operators. However, these guidelines are voluntary and enforcement remains a challenge. What the world needs now is a binding international framework, one that ensures accountability for debris generation, incentivizes cleanup efforts and creates a clear legal pathway for missions involving shared orbital spaces. Futuristic drones offer a unique opportunity to become the backbone of these collaborative efforts. Imagine fleets of drones deployed not by a single agency or entity, but by a coalition of nations and companies working together. These drones could be stationed strategically in key orbital highways, tasked with capturing high-priority debris while sharing data and resources across borders. Advanced AI could coordinate drone missions to maximize efficiency, ensuring that efforts are synchronized rather than duplicated. This kind of collaboration could turn what is currently a fragmented response into a unified global strategy. More importantly, these drones could lay the groundwork for a new era of space governance, one that prioritizes sustainability as much as exploration. By making drones the centerpiece of orbital cleanup, we'd not only address the debris crisis but also set a precedent for future international cooperation in space. Just as the International Space Station brought nations together to conduct groundbreaking research, a global drone network could serve as a unifying force, proving that when it comes to space, our collective efforts are far more powerful than isolated initiatives. Ultimately, solving the space debris problem will take more than just technology. It requires a commitment to collaboration, accountability, and vision. With agencies like NASA and the ESA leading the charge, private companies driving innovation, and futuristic drones offering a scalable solution, we're seeing the first steps toward a cleaner, safer orbital environment. The question now is whether we can scale these efforts fast enough and work together effectively enough to protect the future of space exploration and the countless benefits it brings to life on Earth. Looking ahead, the future of space cleanup technologies promises to be nothing short of revolutionary. With advancements in artificial intelligence, machine learning, and modular drone systems, what once seemed an insurmountable challenge, cleaning up Earth's orbit, could soon become an efficient, repeatable process. These cutting-edge technologies not only have the potential to turn the tide against space junk, but also to lay the foundation for humanity's sustainable presence in space. So, what might these innovations look like in the decades to come? First, imagine highly intelligent cleanup drones powered by advanced AI and machine learning algorithms operating autonomously in orbit. These drones could be equipped with sophisticated onboard systems capable of analyzing their environment in real time, predicting the movement of debris and adapting their strategies dynamically. For instance, with machine learning, a drone could study patterns in how different types of debris behave, like whether a tumbling fragment will slow down or speed up, allowing it to optimize its approach with each successive mission. Over time, these AI-driven systems would only get smarter, using vast amounts of collected data to create more efficient cleanup paths, drastically reducing the time required for each operation. Safety in space cleanup would see a massive upgrade as well. Future drones could operate collaboratively in swarms, much like a team of well-coordinated workers tackling a large project. By exchanging data and adjusting to one another's movements, these drones could handle debris fields of various sizes and complexities without risk of collisions. Picture a modular swarm equipped with interchangeable tools, some drones carrying nets for smaller fragments, others equipped with robotic arms for larger pieces, and perhaps even lightweight drones to scout the area and map debris clusters. This level of coordination not only increases efficiency, but also ensures that the cleanup process remains controlled and precise, minimizing the risk of generating more debris. And speaking of modularity, these adaptable systems could be a game changer. Future drones might be designed with plug-and-play components that can be swapped out depending on the mission's needs. For example, a drone tasked with deorbiting a defunct satellite could be fitted with large magnetic docking systems, while a drone targeting smaller debris fields might use laser systems to nudge fragments into a safe trajectory. This flexibility would make cleanup missions more cost-effective, as a single fleet of modular drones could tackle a wide range of debris types without requiring entirely new designs for each mission. But where things get really exciting is when we consider the potential for resource recovery. Future drones might incorporate onboard recycling technologies capable of processing space debris into reusable raw materials. Think of it as turning orbit into a sustainable resource economy, where the aluminum from old satellites and the titanium from discarded rocket parts are melted down and stored on the drone for future use. These materials could then be delivered to orbital manufacturing facilities to construct new satellites, spacecraft, or even components for space habitats. This shift from viewing debris as waste to seeing it as an asset could transform how humanity interacts with space, creating a closed-loop system that reduces the need for frequent launches from Earth. These advancements in cleanup technology wouldn't just solve the immediate problem of space debris, they'd also set the stage for humanity's long-term presence in space. A clean and well-managed orbital environment is essential for ambitious projects like building lunar bases, establishing Mars colonies, or creating space tourism hubs. The ability to safely and sustainably use Earth's orbit ensures that the next wave of innovation and exploration can proceed without the looming threat of collisions or unusable orbital paths. And beyond practicality, there's a deeper philosophical shift at play. The development of AI-driven, modular drones signifies a broader commitment to treating space not as a free-for-all frontier, but as a shared and precious resource. By investing in these technologies, humanity is taking its first steps toward responsible stewardship of the cosmos, a principle that will become increasingly important as our presence in space grows. The future of space cleanup isn't just about removing junk, it's about redefining how we operate in space. Safer, faster, and smarter drones powered by AI, combined with innovations like modular designs and resource recovery, promise to turn today's crisis into tomorrow's opportunity. And as these technologies evolve, they'll do more than just clean Earth's orbit. They'll ensure that the dream of exploring and living among the stars remains within our grasp for generations to come. The battle to clean up Earth's orbit is about so much more than solving a technical problem. It's about protecting the systems that make modern life possible and ensuring humanity's ability to continue exploring the final frontier. Satellites that enable global communication, provide accurate weather forecasts, and guide disaster relief efforts are critical to our everyday lives. Yet, they are under constant threat from the growing minefield of space debris. Without action, we risk losing these vital tools and jeopardizing the future of space exploration itself. That's why the mission to clean up our orbital highways is not just urgent, it's essential. At the heart of this effort are futuristic drones, the unsung heroes of this global challenge. These incredible machines represent the height of human innovation, blending artificial intelligence, robotic precision, and visionary engineering. They're designed to operate in one of the most unforgiving environments known to humankind, turning a seemingly impossible task into a tangible solution. These drones symbolize more than just technological prowess. They embody the spirit of collaboration, with space agencies, private companies, and nations working together to address a problem that affects us all. They're living proof of what humanity can achieve when we unite toward a common goal. But the battle for cleaner orbits doesn't end with the drones themselves. This effort requires a shift in mindset, a commitment to treating space as a shared resource that must be cared for responsibly. It's about fostering international cooperation, establishing stronger regulations, and holding ourselves accountable for the debris we leave behind. Cleaning up space isn't just about fixing a current issue. It's about preventing future crises and building a sustainable foundation for generations to come. As we look to the future, the story of space debris cleanup reminds us of an important truth. Technology, when wielded responsibly, has the power to transform even the most daunting problems. The same ingenuity that once took us to space is now being used to protect it, proving that progress and responsibility can go hand in hand. This is a pivotal moment in history, a chance to show that humanity's exploration of space can be as thoughtful as it is ambitious. So, how can you contribute to this mission? Start by staying informed and supporting policies and projects that promote orbital sustainability. Encourage conversations about space debris and its solutions, whether it's with friends, family, or online communities. And if you're as fascinated by the possibilities of futuristic technologies as we are, consider subscribing to join us in exploring how innovation is shaping our world and beyond. Together, we have the tools, the creativity, and the collaborative spirit to tackle the challenge of space debris. It's not just about cleaning up the mess, it's about ensuring a brighter, cleaner future for life on Earth and the limitless possibilities that lie beyond. Let us know your thoughts in the comments. What excites you most about the potential of these space cleaning drones, and how do you see technology solving other global challenges? Don't forget to like and share this video to spread the word about preserving the final frontier. We'll see you next time as we continue to uncover the incredible ways technology is shaping the future.